Hey everyone, my name is Prangan Majumdar and I am an engineering student here at the University of South Florida. Go Bulls! So, this semester I'm taking fluid mechanics with Dr. Felicio, which means I officially think about fluids way more than a normal person should. And today I'm about to do a quick fluid mechanics demonstration to show how real world fluids work. Like, I'll use simple things you would find in any kitchen, but I'm gonna use my room because I cannot use my kitchen right now. So we're gonna look at density, viscosity, and buoyancy just by pouring a few liquids into transparent cups and watching how they interact. It's simple, visual, and it explains why some fluids raise, some crawl, and why some objects float differently in different kinds of liquids. So, without further ado, let's jump straight into the demonstration. So, what is density? Well, in easier words, density means how heavy a fluid is for its volume. Denser fluids sink, lighter fluids rise. And we can see that happen in seconds. Here I have honey, which is the densest liquid. I need to squeeze it a little bit. Honey sinks right into the bottom, and I'm not shy about it. I think this much should be enough. Next, I'm adding water on the top. It might look at an instant that it's gonna mix up, but if you give it a second, you'll notice the change. It actually forms its own layer because it is much less denser than honey. And finally, the lightweight champion, oil. I'll add a pretty decent layer so that the difference is clear. Now we have a beautiful three-layer fluid stack. Honey at the bottom, water in the middle, and oil on top. Density differences doing density things. It's cool, right? But it doesn't end here. You know how interesting can I make it? If I pour honey in it, you might say it will sit on the top. But as I pour more honey in it, the honey goes straight down without mixing and just sits at the bottom. Same goes for the water as well. See? It just created another bigger layer of water, but it did not mix with either the oil or the honey. Now let's see what happens when I drop a solid object into this density column. And for that, I'm using a dime. Small, simple, and heavy enough to pass through all three layers. Now let's talk about viscosity. It means how thick or resistance to flow a fluid is. In other words, if I make it easier, high viscosity means it moves slowly, and low viscosity means it slides down fast. Now, watch this. I have water on this cup and honey on this cup. Now, if I pour both at the same time, as you can see, the water is pouring as if it's running late for class. But on the other hand, the honey is taking a long time. As if it is on vacation, a long permanent one. And as usual, the honey is taking its spot at the bottom. So, finally, let me break down whatever happened throughout the video in the point of view of a fluid mechanics problem. At first, the layering. Honey settled at the bottom, water stayed in the middle, and oil floated on top. That's simply because each fluid has a different density. In fluid problems, we usually compare densities using this. Yeah, this weird looking P is the Greek letter rho. So, when the rho of object is greater than the rho of fluid, the object sinks. And when the rho of object is less than the rho of fluid, it floats. And so our three fluids sorted themselves automatically based on their rho values. Next, when I dropped the dime, its motion told us a lot about the forces acting on it. In the oil, the dime fell quickly because the fluid is light and has low viscosity. The resisting drag force was small. In the water, the dime slowed down a little because water is denser, so both buoyancy and the drag increased. Then, in the honey, the dime slowed down dramatically, just like my brain does during exams. That happens because the drag force is directly proportional to the viscosity, which is denoted by this weird looking U called mu, another Greek letter. Even though the dime is still heavier than honey, the resisting force nearly balances gravity, creating that slow, almost suspended fall. With just one cup and a single dime with three liquids, we turned a kitchen setup, a room setup, into a full on fluid mechanics lab. Density, viscosity, buoyancy, all happening just in front of us. We are surrounded with fluid mechanics. So, thanks for watching, and special thanks to Dr. Felicio for this awesome semester. And that's it. Go Bulls!